Welcome to the new session on our engineering geology or geology for civil engineers. So in today's session, we are going to start with our new chapter that is engineering geology. So engineering geology becomes an applied geological aspect where we will be applying the knowledge for civil engineering projects. So in this chapter, we are basically having 5 components. The first component is about geological mapping. Then we have the second session that is basically a framework of geological characteristics of India and Gujarat in specifically, because we are located in Gujarat, so we will give little emphasis into the geological aspects of Gujarat, and we will discuss a little bit about the geological framework of India. Then we will briefly go through the outline of groundwater. So then the 4.4 is the basically the direct application of geological aspects, where we will take some hypothetical situations of geological conditions, and we will try to see that what all parameters we will be taking into consideration while considering that particular area for construction of a dam or a tunnel or reservoir or highways. Then we have the 4.5. So we will start one by one. The first chapter or the first topic we are going to discuss, it is 4.1, that is geological mapping. Maps, it would be a visual representation of an area or a symbolic depiction highlighting the relationship between elements of that space, such as object, regions and themes. Different kind of maps. First one we discussed was a topographical map, then there is a cadastral map, then there is engineering map, then there is a military map, then there is a geological map, then there is an archaeological map. So this kind of different maps we have discussed. But in our situation where we are right now in, is to study a region where we need to nearing structural constructions. So we will be interested into 2 parts of this, that would be the geological map and a topographical map. And as you know already, that the topographical maps are the maps which will be having a topography of the area, or the surface undulations or irregularities in the surface will be shown in the topographical map, and whereas in the geological map it will be showing the geological characteristics such as rock type. Then topography will also be there in the geological map. The contacts between different mythological boundaries will be shown in the geological maps. Okay, so we will briefly see that how these maps are produced and what can be interpreted from that map. For example, if you imagine this is a hill, what you see on the right hand side of the screen, and here the scale, the hill is having a height of around 210 meters, that is the height, and I am, as a surveyor, is standing at the base of the hill. So now I have been given a task to prepare a geological map of this hill. So that is the task given to me. So what I have to do is that first I have to show that okay, this region is having a hill. For that, what I need to do, I need to produce a 2-dimensional map of this hilly terrain. How will I do that? For that, I'll start climbing the hill, and I will reach a position. I will identify the elevation of that position, and for right now I have at a elevation of 50 meters. So I will mark something on that 50 meter. Then I will go a little bit more. I will climb a little ahead of this. Then I will reach another height, and I will see that okay, this is 70 meter. So likewise, the height of the hill I'm climbing, and whenever I climb, I can use any of the instruments. I can use a GPS, I can use a total station, I can use a level, or any of these instruments I can use, and I can find out the elevations of this hill sector. I reached the top of the hill, and where the height of this hill is 200 and 190 meters. So from the base of the hill to the top of the hill, I have marked the heights of equally distributed distances or the elevations starting from 50 meter to 190 meter. Now what I need to do, I need to plot these things into a map or into a paper. That would be my map. For that, these single heights will not work, but I need to continue this survey, and I have to find out all around the hill of these same values. Okay, so this is how I am continuing the process, and I am finding out all the areas where the all around the part of the hill there the hill is showing a 50 meter, let's say a 70 meter, an 80, 90 meter, 110 meter to 130 meter, 150, 170 meters all around the hill. So after doing all this, these processes, what I can do is that I can mark these lines, I can connect these lines together by some markings. Okay, for example, here if I'm putting a light dark brown color for at a 190 meter all around the scale, you just imagine that all around the scale there would be one point, it will be having a 190 meter. Like yellow color I am marked on the 170 meter, similarly 150 meter, then 130 meter, 110 meter, 90 meter, 70 meter and 50 meter. So I did this marking, and now I took a plane and I go to the top of the hill and I observed the hill from the top. Okay, now if I observe this hill from the top, how these lines I am going to see from the top? For example, if I take the 190 meter, I will see this 190 meter all around the hill as a small circle. Okay, so I plot that circle into a map, into my page. Okay, so I got 190 meter into that. Now I will look into the yellow line that is representing 170 meter, and if I see that from the top, if I see that from the top, that is from the from the hill, from the plane, I will see this yellow line that represents 170 meter would be larger than 190 meter. So that would be something like this. Similarly, the 150 meter would be larger than that, then 130 meter, then 110 meter, then 90 meter. Okay, so this is how this entire lines are going to be marked in the map. Or now what I have prepared, what I am having right now in my hand, this is called a map of the area, where what I am having is these values or the lines are, we call these lines are contour. If you remember that in the surveying also you will study the same thing. So what we are having right now, it is the contours. So what is a contour? Contour is the lines which are having equal elevations, line joining equal elevations of a surface. Okay, so this is what we call it as a contour, and these contours will have lines which will contours will have values. So here the primary value of 190 is given to this particular contour, and if I am anywhere inside that, the value should be more than 190, and this is 190 to 170. So if I am anywhere in between, that would be value is going to be between 170 to 190. Okay, similarly I can prepare the contours of any area. So this is the process what you people will be doing it in the surveying also. We have to go a little ahead of this. So for just an example, if this is another contour of an area, where if you see here the value of the contours which are reducing, okay, when you move away from the center of the contour, whereas in this case the value of the contours increases when we move away from the contour. So this we know it was represented by a hill. What would be represented by these contours, where the value at the center is small and which is increasing when we move away from the contour. The outer contour values are increasing. What would be the area which will be representing? This may be representing a basin, or it may be representing something like a lake. Okay, so this is what the contours are representing. Now our system is not, we are not right now considering on the contour. So contour is a process what a civil engineer or a surveyor will be doing. Now we are concerned right now about what is there inside this river, inside this hill. Okay, so this is a hill. What is this hill made up of? It is something cavity inside that, or there will be something inside that. Obviously, when there is a hill, there should be something inside the hill, and the hills are usually made up of rocks, and there are different conditions that the rocks inside the hill. First one, it is what you are considering. First one, what you are considering is a hilly area where the hills are having rock layers, and all these rock layers are horizontally arranged. Okay, we have a rock type that is called shale. What kind of rock type it is? Igneous, sedimentary or metamorphic? It is a sedimentary rock, sandstone, again a sedimentary rock, conglomerate, again a sedimentary rock. So there are three different varieties of rocks which are exposed here in the area, in the hill. And if I cut this hill vertically, then I will see something like this up to one elevation or one height. That for example, if it is around 60 meters, this is 50 and 58 meters, I will have a rock type that is shale. And then I climb. If I am climbing here, I will climb up to 140 meters. Then there would be a change in the rock type I will observe anywhere, because if I climb the hill anywhere, any direction, from any direction, I will see this 140 meters, because the rock types in this region are horizontally arranged. Now the point is that how these rock types will be shown in this geological map. For example, this 140 meter, represents the contact between conglomerate and sandstone. Conglomerate is a one type of rock which will have larger crystals and gravel size sediments, and sandstone is something like a small sediment. So there would be a contact which will be separating the sandstone and conglomerate, and that contact will be at around 140 meter. Because in this area the layers are horizontally arranged, so if I see this hill at this 140 meter, all around the hill I will get this 140 meter change, because 140 meter lithological change. Why? Because this 140 meter is horizontally arranged. Similar like the contour, I will get a line which will be passing through all around this 140 meter contour, 140 meter height. So this will be my lithological contact. Or if I draw it in the map, so something like this would be come. Okay, so which means if I am at 160 meter, what kind of rock types I will get? I will get a rock type at conglomerate. And if I am at below the 140 meters, I will get a rock type which will be sandstone. Similarly, if I see this second contact that is at around 58 meter, and if I draw that 58 meter, so that will be something like this. Okay, so from this geological map, now the topography is along with the lithological characteristics of that area, and below that the shale, and the lower boundary is not shown, so I don't know what exactly the boundary, but this is up to my page, if this is the page. So the area is having three rock types, and the rock types and the topography together, I am able to understand what kind of rocks are present here. If the rock types which are horizontally arranged, what I will see? I will see a lithological map or geological map where the lithological contacts, that is the lithological contacts what I am talking about, this lithological contacts will run parallel to the contours. In all this, there nowhere it is cross-cutting, because the layers are horizontal, so there is no chance of cross-cutting the contours. Similarly, if the rock types are exposed, or the rock types in the region is vertical in nature, if this is how the rocks are in the hill, there are one rock which is the sandstone, and there is conglomerate, and the lithological contacts are vertical. How will we be able to see this when we see it from the top? This contacts will be seen. Okay, this contact will be seen. If I see it from the top, I will see this contact as a straight line from the top, right? So if I see it from the top, I will see something like this straight lines. Or in another way, if I summarize that any vertical feature or a vertical contact of a lithology or geological characteristics of a ground will be represented by a straight line in the case of geological map. This is same for if it is a dike. Okay, if I see a dike, the dike also will be shown as a straight line in the case of a geological map. What will happen if there is the rock types in the area is inclined in nature? How it will be, the lithological contact will be shown in the geological map. Hope you say that these things will be represented in a map with a curved lines which will be cross-cutting the geology or the contours. Something like this. All the rock types of this curved line will be conglomerate. All the rock types between these two lines will be sandstone, and all the rock types below after the contour line will be shales. So I hope that you understood the concept of the rock types. So if you need to summarize, any horizontal feature in the ground will see as line in a line running parallel to the contour in case of a geological map. That is the first information we get. And if the lines are perpendicular, then we will get it as a straight line in the case of geological map. And if these things are inclined, then we will get as a curved line in the case of geological maps.